Welcome to AI Podcasts. I'm Ethan, and today we're talking about Portcullis, a new privacy gateway for using third-party LLMs without leaking your secrets.
Hey everyone, Maya here. Portcullis is such a good name for a privacy tool, a castle gate you can lower when trouble shows up. Quick headline first, Ethan. What's the big idea?
Bottom line, Portcullis puts a hardware-attested privacy gateway between you and an outside LLM. Your prompt goes into a secure enclave, the sensitive bits get swapped out with placeholders, the sanitized version is sent to the external model, and then the gateway restores your original details before handing the result back to you. The service operator can't see your raw data, and you can verify the gateway is running the right code.
So it's like sending a letter where the address and names are temporarily covered with sticky notes, and only your trusted mailroom knows what's underneath, right?
Exactly. And that trusted mailroom lives in a confidential computing enclave. Think of it as a locked room with a peephole. You can check who's inside through the remote attestation, but no one outside can see what's on your paper while it's in the room.
Nice. Who's behind the paper?
Lead author Zhang, with co-author Jiangou among the team. The work appears at Wenhui 2025.
All right, set the scene for us. Why do we even need this kind of gateway?
Plenty of organizations want to tap powerful hosted models, but their prompts can contain personally identifiable information, health details, legal strategy, or trade secrets. If you send that raw to an external API, you're trusting the provider's logs, staff, and infrastructure. That's a big ask.
People have tried a few things already, though, right? There's classic redaction, there's heavy crypto, and there are secure hardware approaches.
Right. Client-side redaction can work, but it gets brittle. Miss one subtle identifier and you might leak. Cryptographic methods like secure multi-party computation or homomorphic encryption are strong, but can be slow and complex for big models. And server-side trusted hardware helps, but if the LLM is truly third-party, you don't always control their environment.
So Portcullis tries to thread the needle. Keep the sensitive handling in a verified enclave you control, but still use the third-party model for the heavy lifting.
That's the pitch. The gateway detects sensitive spans in your text, swaps them with neutral tokens in parallel, calls the outside model with the sanitized prompt, and then remaps the tokens back to the originals on the way out. All the swapping and bookkeeping happen inside the enclave.
I like the word parallel there. It suggests they optimize the swap process, not just running a clunky find and replace loop.
Yeah, they emphasize speed. Against a prior anonymized and de-anonymized baseline called hide and seek, the gateway reports order of magnitude speedups for masking and unmasking, and on an email benchmark, it preserves or improves task quality.
Let's unpack those experiments a bit, but gently. No number salad. What did they test?
They use email-style workloads where prompts include names or other identifiers that you wouldn't want to hand to a third party. They compare to that baseline system and run the sanitized prompts through an external LLM to see if the overall task still works after masking. They also look at system behavior, like how well the gateway scales when you spin up more enclaves.
And the takeaway was basically, yes, it works, and it's fast enough for real deployments.
That's the story. The key result is you don't have to choose between privacy and practicality. By pushing the sensitive steps into an attested enclave, you reduce exposure, and by keeping the main inference on the third-party model, you keep the power and convenience.
Can we slow down a second on the word attested? What does that mean in real life for an engineer listening?
Sure. Imagine your app asks the gateway, "Who are you really?" The enclave provides a cryptographic receipt saying, "Here's the exact code and environment I'm running." Your app checks that receipt against a known good measurement. If it matches, you proceed. If it doesn't, you refuse to send data.
So the client can prove the lock on the door is the one they expect, not a cardboard cutout.
Exactly. It's verifiable in that specific sense. You can verify the gateway's identity and configuration before you trust it with secrets.
Let's talk detection. How does the gateway find sensitive stuff in the first place? Names and emails are easy, but what about the squishier things?
The paper leans on entity detection and patterns. That covers names, emails, phone numbers, those sorts of identifiers. But, and this is important, pattern-based detection can miss semantic clues. Like the only cardiologist on the Tuesday shift at a small clinic, You didn't say the person's name, but everyone on that floor knows who you mean.
Right? So the classic problem of implicit identifiers. Even with a very careful redaction brush, those silhouettes can still be recognizable.
Exactly. Portcullis lowers your risk a lot by stripping obvious identifiers, but it isn't magic. If your text reveals identity through context, the sanitized version may still leak something.
What about the third-party model side? Is there any guarantee the provider won't leak something on their end through logs or timing?
The gateway limits what the provider sees by sending only sanitized text, but it doesn't control their infrastructure. If you need absolute secrecy end-to-end, you'd want the serving environment itself to be confidential, possibly including GPU-level protections and strict logging policies. Portcullis improves the picture, but doesn't certify the provider.
Good to be clear about that. Verifiable here is about verifying the gateway, not proving that the outside model followed the rules.
Correct. Think of it like a privacy airlock. The airlock is trustworthy, and it ensures nothing sensitive exits. Once the airlock hands off the clean payload, you still need to trust the room beyond, just a lot less than before, because the payload is bland by design.
Let's touch on utility. Listeners might wonder, if you strip names and IDs, won't the model just get confused?
It depends on the task. For many cases, the model mostly cares about structure and semantics. If Alice Johnson becomes person A, the model can still write a reply, summarize, or translate. Then the gateway swaps person A back to Alice Johnson on the way out, so the final text reads naturally.
That's like sending a draft to a freelance editor with all the client names replaced by code names. The editor fixes the grammar and flow, and you put the real names back before sending the final version to the client.
Perfect analogy. And the authors show that this kind of pipeline can be both quick and faithful enough for day-to-day workflows.
Any engineering details on scaling worth calling out?
They stress that the gateway is containerized for confidential execution. In practice, that means you can run many instances and bring them up or down as demand changes. Startup time and parallelism matter because you don't want your privacy layer to become the bottleneck.
Now the tough part. What gave you pause?
3 things. First, sensitivity detection is only as good as its rules and models. That's a moving target. Second, side channels elsewhere in an LLM stack, like cache sharing or scheduling quirks, can leak information even when inputs are sanitized, though the sanitized input helps. Third, verifiability stops at the gateway boundary. If you need proof of correct behavior from the external model itself, that's a different research frontier.
I'd add reproducibility. I always look for public artifacts. If teams can rerun the pipeline on common datasets and confirm the results, it builds trust.
Totally. And one more operational note. If you are dealing with highly regulated domains, you still need policies around prompts, redaction rules, monitoring, and data retention. A gateway is a building block, not the entire compliance story.
What would you like to see next from this line of work?
Smarter detection that goes beyond patterns into semantics, maybe with risk scoring for context-based identifiers. Tighter integration with privacy-aware serving on the provider side, so the sanitized prompt doesn't meet a leaky system. And, when feasible, confidential hardware across the full path, including accelerators, plus standardized benchmarks and shared code for the community.
I'm also curious about lightweight checks that let the client verify the external model didn't do something obviously out of policy. Not a full cryptographic proof, but a breadcrumb trail the client can validate.
Yeah, hints or fingerprints that give you accountability without grinding performance to a halt.
All right, bring us home. If someone only remembers one thing about Portcullis, what should it be?
Portcullis is a practical way to use third-party LLMs while keeping your sensitive details inside a verifiable gateway. It swaps secrets out before the call and restores them after, all in a locked room you can inspect. It won't solve every privacy problem, but it meaningfully lowers risk without giving up the benefits of external models.
Nicely put. My coffee-sized takeaway is this. Treat privacy like an airlock. If the room beyond isn't fully under your control, at least make sure only sanitized air gets through, and verify the airlock itself is the one you installed.
And that's Portcullis in a nutshell. Thanks for listening.
This was AI Podcast. If you enjoyed the conversation, share it with a colleague who worries about prompts and privacy. See you next time.